So section 8.3, polynomial division, the remainder theorem, and the factor theorem. And a lot of this stuff goes back over some of the stuff that we've already talked about in 8.1 and 8.2. So if you're following along on Zoom, if it gives you the equation and then it says, and it also factors it for you, right? So they factored it out for us already. What do these things mean? What are these things that related to the graph? Let's go. They should be your zeros, right? When you solve this, when you solve x plus 3 equals 0 and you subtract 3 and you subtract 3, you get x is -3. You should have a 0 at -3. So if you're following along on Zoom, you should say, well, these are finding, either say they're your x-intercepts or they are your zeros. X plus 1 equals 0. You would subtract 1, and so you get -1. That's one of your x-intercepts or your zeros. The other one is x minus 2. So when we're solving that, we get x equals 2. That's one of your zeros or your x-intercepts. So this next question says, well, what are the factors? And I actually meant to underline that, not mark through it. Sorry about that. What are the factors? Well, what are factors of, if I ask you what are factors of the number 10, you're going to tell me what? What's a factor of the number 10? Spencer Davis says that 5 is a factor of 10, and I agree with him. 5 is definitely a factor of 10. What's another factor of 10? 2. What's another factor of 10? 1, 10. So factors are numbers that go in evenly to these to the number, right? They don't have any remainders. If they're a factor, they go, you can divide them in evenly and they have no remainders. So that's what a factor is. So when they say, what are the factors of h of x, is what it's saying. Well, it's these things. X plus 3 is a factor of h of x. X plus 1 is a factor of h of x. X minus 2 is a factor of h of x, because they go in evenly to that number and they don't have into that polynomial and they don't have any remainders. Well, the zeros that go along with those factors are -3. They're always the opposite of whatever's up here, right? -1 and 2. When we solved x plus 3 equals 0, we got -3. That was a 0. Those are your x-intercepts that we plotted. Okay, so everybody okay with that? Now, example 1 says, determine if x plus 3 is a factor of h of x equals x to the third plus 2x squared minus 5x minus 6. So in 8.1 and 8.2, both of those lessons, we talked about, well, when you solve x plus 3 equals 0, you would subtract 3 and you would get x is -3. And then if you go in the polynomial function that we're talking right here, and it's every time you see an x, you plug in a -3. For the answer, if you get 0, okay, because it's supposed to be a 0, right? It's supposed to be an x-intercept, which is a 0. Then it is a factor. If you don't get 0, it's not a factor. So you would go to your calculator and you would type all that stuff in. I'll just write a little bit of the workout for us. But -3 cubed would be -27. This would be 9, so +18 plus 15 minus 6. And all of that stuff does end up being 0. So x plus 3 is a factor. So that's one way for me to tell. So we started with x plus 3. We took the opposite of the plus 3, right? And we checked to see if the negative 3, which is our 0 there, gives us 0 when we plug it in. Okay, everybody good with that? Okay, we talked about that in 8.1 and 8.2 as well. So solving this problem using division. Yeah, so the first long division is just, is to me, well, to me it's not difficult, but for a lot of students it is, and I know that. So I'm gonna go slow. But the hope is that this long division, you really don't have to use that because we have this nice thing called synthetic division that we're able to use. But I do want to show you the long division and kind of compare them, and then you're going to probably decide that you want to use the synthetic division. But some people might have an easier time with long division. So that's really up to you which one you want to use. So here's the steps. You're going to look at this x that is in the front, and you're going to look at this x to the third. And you're going to say to yourself, what would I have to multiply this x in the front by to get x to the third? Okay, what would you have to multiply x by to get x to the third? Well, the answer to that is x squared. And you want to scoot over and put that here. So, and you're going to see why in just a minute. So the question is, what do you have to multiply x by to get x to the third? Because you want it to go away. So now you're going to take this number that we picked, or variable that we picked, x squared, and you're going to multiply it by x. So x squared times x is x to the third. You're also going to take this x squared and you're going to multiply it by the 3. And x squared times 3 is positive 3x squared. So I took the x squared, I multiplied it by x, and I multiplied it by 3, and I wrote it down there. So the whole goal here when we do this is that when we subtract these, and I'm putting it in parentheses because I've got to subtract the x to the third, and I have to subtract the 3x squared. That this first term should disappear. That was the whole reason we did it. So we could get that first term to go away. So x to the third minus x to the third is nothing. You just leave it blank. You move over to the next term, 2x squared minus 3x squared. You make sure you go pick up that minus. 2x squared minus 3x squared is negative 1x squared. So after we got rid of that first term, now it's going to be our goal to get rid of negative 1x squared. We're going to bring down this next term here, this minus 5x. We're going to move it down. And so we're going to say to ourselves now, we're going to look at this x in the front. We're going to say, what do I have to multiply x by to get negative 1x squared? Because we want it to go away. We want it, when we subtract it, we want it to turn into 0. So we would have to multiply x by negative 1x to get negative 1x squared. So that's what we're going to do. We're going to take the negative 1x and we're going to multiply it by x. That's going to be negative 1x squared. We're going to take the negative 1x and multiply it by the positive 3 and get negative 3x. So I took the negative 1x and I multiplied it by both the things over here. What do I need to do now? Subtract everything in that bottom term. So negative 1x squared minus negative 1x squared. Well, a minus minus is a plus. So really this is negative 1x squared plus 1x squared. It turned into 0, which is exactly what we wanted. Okay, negative 5x minus a negative 3x. Well, minus minus is a plus. So we're really saying negative 5x plus, because minus minus 3x. So negative 5x plus 3x is going to be a negative 2x. We're going to bring this last negative 6 down. Okay, we're almost done. We're going to ask ourselves, this term in the front is what you want to get rid of. So this is what we need to get. What would we have to multiply x by to get negative 2x? Negative 2, right? So negative 2 times x is negative 2x. Negative 2 also gets multiplied by the positive 3, which is negative 6. Then you want to subtract. So negative 2x minus negative 2x is 0, right? Because negative 2x minus a minus is a plus. So this is really negative 2x plus 2x, nothing. Negative 6 minus a minus 6 is nothing. So we got 0 here, which means we don't have a remainder, which means that x plus 3 is a factor of x to the third plus 2x squared minus 5x minus 6. It goes into it exactly x squared minus 1x minus 2 times. We divided it, it worked, we got a remainder of 0. Okay, here's the exact same problem. Well, first off, any questions about that? Here's the exact same problem using synthetic division. So synthetic division is not a piece of cake, but it's a whole lot easier to understand than this. So when the problem looks like this, the first thing you're going to have to do is go, okay, x plus 3, and you're going to have to go make that a negative 3. So you want to do the opposite of whatever was there, right? Then you want to go pick up the coefficients of your term. So we have an x to the third. Well, what number's in front of x to the third? 1. We have a 2x squared. There's a 2 in front. Negative 5x, negative 5, negative 6. So that's where we got those things from. Any questions about that stuff? This part is very important. This one worked out nice because we had an x to the third, an x squared, an x, and a number, okay? They have to be in order. So let's say this problem skipped this term right here, and it was just x to the third plus 2x squared minus 6. I would still put the 1 for the x to the third. I would put the 2 for the 2x squared. For the negative 5, I have to put a 0 there if there's no x terms there. It has to go in order, and then the minus 6 would go on the end. So if it skips one of the successions of x to the third, x squared, x to the first, you have to put a 0 to hold that spot. Okay, and you would have to do that in long division as well. So first step here, you're going to bring the 1 down. You're going to take the 1, going to multiply the 1 by negative 3. And that goes, 1 times negative 3 is negative 3. That goes right underneath the 2. Going to add those two numbers together. So 2 and negative 3 is negative 1. You're going to take that negative 1. You're going to multiply it by the negative 3. Negative 1 times negative 3 is positive 3. You're going to take that positive 3 and write it right here. You're going to add the negative 5 and the 3 and get negative 2. You're going to take that negative 2 and you're going to multiply it by the negative 3 in the front. And negative 2 times negative 3 is 6. Add those two together. Negative 6 plus 6 is 0. This is our remainder. We didn't have a remainder, right? It's 0. So my opinion, we're done. So in my opinion, that's a lot easier understanding this process than understanding this process. So how do you use the 1 and the negative 1 and the negative 2 to get the actual answer? What happens when you divide these? Okay, well, those are the coefficients. So if we started out with an x to the third, your answer is going to be 1 less than that. So if you started out with x to the third, this first one's going to be an x squared. And then this is going to be your x. And this would be your constant term. So my answer would be, well, yeah, x plus 3, my 0 would be negative 3, goes into this exactly. And my it goes into it exactly 1x squared minus 1x minus 2 times. That's the answer. Same thing we got up here, x squared minus 1x minus 2. It's the exact same thing. Just a different way to work the same problem. Okay, is everybody good? So let's look at just a few more examples of this. This tells you how to do this in words. For some of you that may be really like that's your learning style, that may be good for you. I would never be able to process all that with words, but there it is in words. So let's go through another one. Let's go through another example. So they're asking me to use synthetic division, which is what we did, to find the quotient and the remainder. So the quotient is an answer to division problem, right? So we're doing the exact same thing we just did. So if I start out with x plus 3 and I start making this synthetic division, what do I put right here? -3, because it's always going to be the 0. It's not going to be whatever was right here. It's the opposite of that. So then we're going to come over here and say 2. Well, that represents the x to the third. Then I'm going to put 7 because x to the third, the next one would be x squared. That's good. Then I don't have a x, right? It's x to the third, x squared. We don't have an x to the first. So what do I have to put? 0. Then I can put the -5. I put that 0 there because I needed an x to the first, so they would go in order. Is everybody okay with that? Draw this line right here. When I get done, this last term in this little box, that's going to be my remainder. Okay, so anybody have questions about how we set that part up? We're going to bring this 2 down. That's the first step. Take the 2 and we're multiplying the 2 by the -3. And 2 times -3 is -6. What do you do with the 7 and the -6? You add them. 7 plus -6 is 1. Then you just keep on going in this circle. You're going to say 1 times the -3. And 1 times -3 needs to land right underneath the next term. It's -3. Those two terms right there get added together. 0 and -3 is -3. We're going to take the -3, go back in the circle, times -3. -3 times -3 is 9. It goes right here. Adding these. -5 and 9 is 4. So we did not get 0. So what that means is x plus 3 is not a factor of 2x to the third plus 7x squared minus 5. It does not go evenly. We did not get a remainder of 0. We got an answer, but it has a remainder. Just like if you did, if you said, how many times will 5 go into 11, right? 5 will go into 11 2 times. 2 times 5 is 10. When you subtract that, you got a remainder of 1. So we have a remainder of 4. So how do we write the answer? We're still going to take the 2 and the 1 and the -3. We started with an x to the third. I'm getting that 2, 1, -3 from right here. So we started with an x to the third. So we would say x squared, 1 less than that. It's a +1, so plus 1x minus 3 plus. We have a remainder, so we have to include that, plus the 4 part of the remainder goes on the top. What we were dividing by goes on the bottom. So it looks like 4 over x plus 3. If they ask you to write the answer, that's what the answer looks like. If they just ask you for the remainder, you're going to say 4, right? Okay, because if I were to write on this one, if I said, how many times does 5 go into 11? It would be 2 and 1, because we had a remainder of 1 over 5. What we're dividing by what goes on the bottom of the fraction. What we're dividing by is x plus 3. It goes on the bottom of the fraction. The remainder part goes on the top. Okay. Questions about that? So if this is my problem, example 4 says, given that f of x is equal to 2x to the 5th minus 3x to the 4th plus x to the 3rd minus 2x squared plus x minus 8. It says find f of 1. Hey, don't forget everything you've learned so far in here. If it says find f of 1, what do? You plug it in, right? All you have to do is go, okay, I'm find f of 1. So every time I see an x, I'm supposed to put a 1. I'm supposed to drop a 1 in there. That's what it's asking me to do. It's asking me, what's the answer if you put 1, if you plug 1 in? So this would be a 2. This is minus 3 plus 1 minus 2 plus 1 minus 8. So negative, it ends up being -9, I think. Yeah. So from that, we could talk, is 1 a 0 in this problem? Like if I graph this, would 1 be an x-intercept? No, because if it was an x-intercept, what would I have gotten instead of -9? 0, right? Okay, so y'all are getting it. So if I plug 1 is not an x-intercept, it has a point on the graph, it's at -9, but it's not an x-intercept because the answer is supposed to be 0 if it's an x-intercept. If it's a factor, x minus 1, that would be the, so what, if this was, this would be what goes with it because we would look for the opposite, right? X minus 1 would be +1 when we're looking at the 0. So x minus 1 would not be a factor of this. I could divide it out with synthetic division, but it's not going to come out as my remainder of 0. Okay, anybody have questions about that? So example 5, it says determine whether 5 is a 0 of g of x. So can I use synthetic division to do that? To determine if it's a 0? Absolutely, I can use synthetic division. If I get a remainder of 0, it's a 0. But I can also do what? Plug it in, right? I could say, well, let's see, it's 5 a 0. So that means I'm going, let me plug in 5 every time I see an x. And if the answer is 0, which it is, then it's a 0. 5 is a 0. The factor part that would go with that would be the opposite. It would be x minus 5, right? If I wanted to use synthetic division to prove the same thing, I would still put 5 here because x minus 5 would be the actual term, the factored part that goes with it. So I would go, oh, x to the 4th, that's a 1. Do I have any x to the 3rds? So 0, x to the 3rds. X squared, I have -26 x squared. How many x to the first powers? None. So I have to put 0 for that. And then 25. So I'm bringing down the 1. 1 times 5 is 5. We're going to add those. Keep going. 5 times 5 is 25. -26 plus 25, -1. Times 5 is -5. Add those, we're going to get -5. -5 times 5 is 25. This last term is 0 because we're adding that. So it has a remainder of 0. So there's another proof that yes, that is a 0. 5 is a 0. It goes into it evenly. If I were to write the answer for this, I started with an x to the 4th. So this would be 1x to the 3rd plus 5x squared minus 1x minus 5. When you divide this by this, x minus 5. Okay. Not bad, right? Okay. Most of the ones that you're doing in the computer lab are, you seriously can just 2 things. I'll say 2 things to you. You're going to have some problems that look like, let's say this is your example. If it says f of x is equal to x to the third plus 2x squared minus 5x minus 6, and it's going to have multiple parts. It's going to say, see if this is a 0, see if this is a 0, see if this is a 0. I would, if this is me and I'm working this problem, I'm going to go straight to y equals in my calculator, and I'm going to type this in. And then I'm going to go to my table. And on my table, I'm going to look at, what does 2 give me? What does -3 give me? What does 0 give me? Because if they give me 0, then the answer is yes, they're zeros. If they give me -5, this is just an example. No, it's not a 0. -3 is not a 0 if it gives me -5 for the answer. Does that make sense? So if that's my problem, I can't tell whether y'all are doing synthetic division or not. if you're working on the computer lab, right? Type it in, especially if it has multiple parts, and look at your table. If the answer on the table is 0, then the answer is yes, it's a 0. If it's not, it's no. Okay. So that is the end of 8.3.